Okay, let's just dive right into this explainer. We're going to look at a massive systems-level climate analysis of a scenario that sounds completely impossible, but the physics are absolutely real. Earth is our main character here, and it's about to experience a staggering physiological shock. The question is, what if the entire Sahara Desert suddenly became a continental glacier?
To understand this, you kind of have to rethink what the Sahara actually is. It isn't just an empty expanse of sand. It's a highly active 9.2 million square kilometer heat engine, basically a vast planetary furnace that shapes weather across 3 continents and 2 oceans. So what happens if you take that dark, heat-hungry terrain and instantly transform it into a blinding white, frozen reflector? Well, you don't just change the local weather. You literally rewire the operating system of the entire planet.
Let's start with part 1, freezing Earth's greatest furnace.
Picture this progression playing out across North Africa. It starts with an anomalous, relentless snowfall just blanketing those burnt ochre sands. Soon, the dunes themselves freeze solid into these static, icy waves. Then, as atmospheric moisture keeps dumping down, creeping ice channels are carved right through the desert valleys. And finally, the whole thing locks in, a permanent 3-kilometer-deep continental ice sheet spreading across the entire region. Just like that, the planet's biggest heat engine is officially offline.
Which brings us to part 2, the global energy shock.
Now, the sheer scale of this change comes down to something called the albedo effect, or surface reflectivity. Right now, the Sahara's dark sand and rock have an albedo of about 0.25, meaning it absorbs roughly 75% of incoming solar radiation. But fresh glacier ice, that has an albedo closer to 0.75. So by freezing the desert, we're replacing a voracious heat absorber with a surface that reflects up to 90% of sunlight straight back into space. It's basically like taking the polar ice caps of Antarctica and plopping a continent-sized mirror right near the equator. The sudden elimination of all that heat is staggering. The Sahara currently absorbs roughly 4 to 5 times 10 to the 22nd power joules of solar energy every single year. To put that completely massive number into perspective, that is the equivalent of thousands of years' worth of total human energy consumption. When that heat absorption suddenly drops to zero and switches to pure reflection, it injects an enormous cooling impulse directly into Earth's climate system. The result? This triggers a massive global mean temperature drop of 2 to 4 degrees Celsius, all happening within mere decades. And if that doesn't sound like a lot, remember that during the absolute peak of the last ice age, about 21,000 years ago, the planet was only 4 to 6 degrees colder than it is today. So this artificial planetary shock unleashes cooling pressures that rival the onset of a full-blown glacial period.
Moving on to part 3, severing the dust lifeline.
Here is where the butterfly effect gets really devastating. You see, the Sahara's greatest gift to the planet is actually its dust. Every year, up to 182 million metric tons of it are swept up into the sky. And crucially, that dust carries about 22,000 metric tons of vital phosphorus right across the Atlantic, where it lands directly on the Amazon rainforest. The Amazon actually has incredibly nutrient-poor soil, so it relies heavily on this exact phosphorus to survive. If we freeze that dust under a glacier, we physically cut off the fertilizer. Without it, we trigger a slow nutritional starvation of the rainforest, eventually degrading one of Earth's most critical carbon sinks. But wait, before that global cooling even fully kicks in, there's an immediate atmospheric terror right over the ocean. Normally, there's a dry, dusty mass of air called the Saharan air layer that acts like a shield over the Atlantic, providing wind shear that literally rips developing tropical storms apart. With the desert frozen, that shield vanishes. Without it, we enter a terrifying, decades-long window of unprecedented, highly destructive Atlantic hurricanes. The ocean essentially becomes an unchecked breeding ground for megastorms.
Next up, part 4, starving oceans and rainforests.
So, while the Amazon is starving for phosphorus, the ocean faces its own biological collapse governed purely by missing dust. The Atlantic Ocean desperately needs Saharan iron. Without that iron blowing out to sea, massive phytoplankton blooms just fail to materialize. And if you lose the phytoplankton, the zooplankton face immediate starvation. Without them, small fish die out, and the marine food chain collapse cascades all the way up until tuna, seabirds, and whales are left suffocating in a biological desert. The Central Atlantic's productivity quietly and steadily diminishes over decades. Back in the rainforest, the timeline of this decline is incredibly haunting. It takes about 50 to 100 years, but the nutrient depletion slowly, relentlessly starves the Amazon. The leaf area density drops, overall plant productivity falls off a cliff, and the forest absorbs progressively less CO2. It's wild to think about, but it perfectly illustrates how deeply intertwined these planetary biomes really are. You literally cannot freeze a desert in Africa without starving a jungle in South America.
Section 5. Reshaping coasts and winds.
Now, a glacier, this incredibly massive, doesn't just appear out of nowhere. It has to steal its water directly from the sea. For some context here, if the entire Greenland ice sheet melted, global sea levels would rise by about 7 meters. But the Sahara is 3 times larger than Greenland. Creating a 3-kilometer thick ice sheet over it would suck so much moisture out of the global system that sea levels would actually plummet by 8 to 12 meters. This dramatic drop would completely drain shallow continental shelves, expose massive tracts of new land in places like the English Channel and Southeast Asia, and push coastlines kilometers outward. This massive shift in atmospheric motion completely rewrites regional survival. The most striking cinematic change happens right across the Mediterranean. Freezing cold air draining off the new glacier pushes north, slamming into the comparatively warmer waters of the Mediterranean Sea. This brings explosive, violent storms and unprecedented flooding to southern Europe and North Africa, completely shifting growing seasons and leaving Western Europe absolutely freezing.
Section 6. Ecosystem transformation. As always, nature tries to adapt, but this sudden thermal shock completely reshapes the global map. As the North Atlantic and Mediterranean waters cool down significantly, cold water-adapted species like cod and pollock suddenly expand their ranges far to the south. Meanwhile, tropical warm water species, including highly vulnerable reef systems and sea turtles, are forced into a rapid retreat. They get pushed closer and closer to the equator just to survive the chilling ocean temperatures.
Finally, Section 7, a stabilized frozen equilibrium.
At this point, the dominoes are falling with terrifying speed. We're watching a chronological cascade that permanently locks the planet into a completely new geological epoch. It forces a fundamental, permanent alteration of humanity's relationship with the Northern Hemisphere. The sheer speed of this destabilization is pretty staggering when you look at the timeline. Year 1 brings the first failed African monsoons and historic, devastating European freezes. By year 5, the atmospheric systems start settling into these harsh new regimes, which peaks unprecedented global refugee and food crises. By year 20, the new ecological trajectories, like the starving Amazon and shifted jet streams, are officially locked in. And by year 100, the planet enters a stabilized, unrelenting century of ice.
So I want to leave you with this final thought. We've just gone through this speculative explainer showing how cooling a single desert can collapse marine food webs, starve the Amazon rainforest, and literally freeze continents. Understanding this incredibly massive, intertwined climate system shows us exactly why we have to be so careful with the planetary balances we are currently shifting in the real world today. Because if freezing the Sahara causes this much global chaos, what on earth are we unleashing by heating it? Think about that for a second and keep exploring.